Hi guys, so I thought I'd make you a video to walk through the study guide so that you guys are fully prepared for your test. So let's get started. Question number 1 says find the number of combinations. Remember, you don't need to show formulas here, you just enter this in your calculator. The calculator command is math, and then you go to probability and you choose NCR. So you do math, choose probability, and then you click the NCR option, which is number 3, and then you just enter this in. Okay, so 4, choose 3, you get 4. Alright, and then 18, choose 4, you get 3060. Maybe I'll make you guys a separate video on all the calculator stuff for this chapter. But I think most of this I did actually make videos for already, but I might do that for you. Alright, so use the binomial theorem to write the binomial expansion of that binomial. Alright, so here we said, remember, we could have actually answered this question that way as well. It's faster if you know Pascal's triangle to find all the combinations I'm going to need to simplify something like this. Okay, so Pascal's triangle, if you remember, works like this. It's just each number is the sum of the numbers above it. I should have started a little bit further in here so I have some more space. In any case, 1, 3, 3, 1, and then 1, 4, 6, 4, 1, and this is the row number. Okay, so this is row number 1. This is row number 2, number 3, number 4, and since my binomial is to the 5th power, I need the 5th row for the binomial coefficients. So I go to 1, 5, 10, 10, 5, 1, and this is the 5th row, so I know that this number here represents 5, choose 0, this number represents 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, and 5, choose 5, which those are the numbers that I need, the binomial coefficients I need for my binomial expansion of this binomial. Okay, so many ways you can do this. I showed you at least 2 in class, but we can say I have my binomial coefficients and I'm going to do some magic here. And again, just to give myself some more space, I'm going to move this up here, okay? So those are the coefficients I need. And I'm going to start by writing out the binomial expansion. So how it works is 5, choose 0. And then I take the first, which we called A, the first term here, and we raise it to the power 5, or to the power n. So this would be my n. This would be my A term, this would be my B term, if we look at the formula. I don't want to write the whole formula, that's just going to make life unpleasant for you. But so there is the A term, which is 3c to the 3rd, and I raise that to the 5th power. And then the way that binomial expansion works is I take the second term, or the B part, which is all of this, and I raise it to the 0 power. Okay? And then I say plus, and now I just keep going with the binomial coefficients. So this is 5, choose 0. Now I do 5, choose 1, 5, choose 1. And then I do 3c cubed, my A term, to the 4th power now. So I decrease by 1. And then I do negative 2d to the 1st power. Plus 5, choose 2, 3c cubed to the 3rd, negative 2d to the 2nd, and so on. Plus, so I'm going to have to wrap around, and that's fine. 5, choose 3, and then I do 3c cubed again, but my previous one was 3rd power, so this is 2nd power, and notice that these two things must add up to 5. Okay, let me switch to a different color here. These two powers must add up to 5. They must combine to give you the nth power that you're working with. Okay, so that's how you know that you're doing it partially correctly at least. All right, so and then plus we did 5 choose 2, we did 5 choose 3. Now I'd have to do 5 choose 4. 3c cubed to the first power and negative 2d to the fourth power, plus the last one is 5 choose 5, 3c cubed to the 0 power, and then negative 2d to the fifth power. Alright, so this is everything done. That's basically half the work. Now I just have to clean it up. Okay, now just to clean it up. So if I write it out a little bit more of a neat fashion, I replace my binomial coefficients, these things, I replace them with the numbers from Pascal's triangle, which is why we did all of that, of course. So I get 5 choose 0 is 1, right here, check, I'm done with that one. And then I do, so 1 times 3 to the 5th, and 3 to the 5th is 243, and then c to the 3 to the 5th, c cubed to the 5th, which is c to the 15th power. Okay, oh, that looks ugly. C to the 15th power. Times, and then I do negative 2d to the 0, well, anything to the 0 is 1. Okay, so what I'm going to do is take each term and simplify it a little bit. Not completely, because it takes some doing. So we're going to do 2 rounds of simplification. Okay, simplify it a little bit, and then in the end we can just write the final answer in a very neat, simplified fashion. Okay, all right, so let's do the next one, plus, so I'm done with this term. Okay, so now I do 5 choose 1, and that says it's 5 up there, okay, and then 3 to the 4th power, 3 to the 4th power, that would be 81. Okay, and then cubed, c cubed to the 4th would be c to the 12th, times, and then now I have a problem here. Ooh, a negative to an odd power is still negative, so I'm just going to write it like this. Okay, you can directly change the sign already to a minus, because it's all of this is multiplication, and it's a plus times a minus, but I'll just go slower and leave it like that. Okay, and then plus, so we're done with this term. Next one is 5 choose 2, 5 choose 2 is 10, and then 3 cubed is times 27, and c cubed is c to the 9th power. Okay, and then times negative 2 to the 2nd, that's a negative squared is positive 4. I don't know why I'm putting parentheses, I might as well just do it like this, 4, and then d squared, plus, and okay, we're done with this term, and then this term, 5c cubed, that's 10, according to our Pascal's triangle, and then I don't want to put a parenthesis, let's do 3 squared is 9, times c cubed squared is c to the 6th, and then I have negative 2 to the 3rd power here, negative 2 to the 3rd power. So that will actually be times, I will put this one in parentheses, that'll be negative 8, and then d cubed is d cubed. Alright, and then plus, so I'm done with that one. Now we do this one right here. 5 choose 4, 5 choose 4 is 5 from my Pascal's triangle up there. And then 3 to the 1st power is just 3, c cubed to the 1st power is just c cubed, times, and then negative 2 to the 4th, that's positive 16, times d to the 4th. And then my last term, 5 choose 5, you know that, anything on the edges there is always 1, so plus 1, and then 3, all of this to the 0 power is 1, and then I have negative 2 to the 5th, which ends up being negative 32, okay, and then d to the 5th is d to the 5th. Alright, that's all the hard work done. Now we're just cleaning up. Okay, so 1 times 1 is 1 times 243, that's just 243 c to the 15th. Okay, then let's multiply again. So I'm done with this term again. Now I have 5 times 81 times negative 2. Well, that's a negative because it's a positive times a negative. And if I multiply all that out, you get 810. Okay, 5 times 81 times 2, it's 810. C to the 12th and D to the first power. All right, done with this term. Then the next term, so I get plus 10 times 27 times 4, which is also big. Looks like it's 1080. And then C to the 9th and D to the 2nd. Okay, done with that term. Next term, now I have a negative again. So a negative times a positive, that's a negative. And now I'm multiplying 10 times 9 times 8. And if you do all that, you get 720. C to the 6th and D to the 3rd. Okay, and then this one, all of those are positive, so I'm going to get a plus, and then 5 times 3 is 15 times 16, so I get 240. Oh, yeah. And then I get C cubed and D to the 4th. Okay, and then the very last term, I'm going to squeeze it in here, is a positive times a negative, so that's a negative, and then 1 times 1 times 32, that's just 32, and D to the 5th. All right, so we're done with this term. Okay, so that shows all the work, that's the whole thing. Obviously, I'm taking a very long time to do this because I'm trying to explain it to you as I go along, but that's what you would get. Okay, all right, number 3. You want to buy some games on Steam for your birthday, and there are 6 games that you would like to buy. Your parents have said that they're willing to buy you 3 games. How many different combinations of games can you buy? This is too easy for you. I really apologize. We have to give you some easy questions to help help you get a good grade. Okay, so you want to buy some games on Steam for your birthday. There are 6 games you'd like to buy. Okay, so total is 6, and I can buy 3. So from the 6, how many ways can I choose 3 games? Okay, so this would be 6 games, and I can choose any 3 of them. Order is not important, and so there's 20 ways if you do that on your calculator. All right? Right, number 4. So please remember, this was a combinations question. Number 4, very different question. Okay, number 4 is a probability question. Please remember this. I saw on your quiz that some of you did this incorrectly. Some people got answers like 20 for probability. You can't have an answer like 20 for probability. Probability is a number. So if P is probability, it's a number between 0 and 1. It can be 0 and it can be 1. Rarely, but it's possible. Okay? And so, please, you should know immediately, if you're writing down an answer like this is equals to 5, you know you're wrong, because probability can't be a number bigger than 1. Many people actually did this in your quiz. Okay? So, according to a survey, about 41% of U.S. households have a soccer ball. Suppose you ask 6 randomly chosen U.S. households whether they have a soccer ball. Okay? Calculate the probability that only 2 of them have a soccer ball. Or exactly 2 of them, I should say. So this is tricky. How am I doing this? What's going on? All right? So you have to think, when you see a paragraph like this, you're thinking, well, it's hard for me to conceive of how to calculate probability. Let me see if this fits the binomial experiment conditions that we had. Okay? Now the conditions we had were that I know the probability of success. So this is the probability of success right here. This is the probability of success, all right? Or what we called P in a binomial setting, okay? So we'll just see if it fits. And so this says, according to a survey, the truth is that about 41% of U.S. households have a soccer ball. So this is telling me the probability of success is about 0.41. Okay? The next condition was that the trials have to be independent. So you have to think about it. Are people independent of each other? If you buy a soccer ball, does that make me buy a soccer ball? So it seems like households would be independent of each other, roughly. Okay? And especially if I'm selecting random households, there's a very little connection between my household and yours if we're randomly selected. Okay, so seems like the trials are independent. Okay, then the other thing was we need to know how many trials there are in advance. And they say, suppose you ask 6 randomly chosen households. Alright, so my number of trials is 6. Okay, and we called this letter N in our binomial experiment setup. Okay, and then it says, calculate probability that 2 households have a soccer ball. Well, this would be what we call K, which is a number of successes. The question is asking for a particular number of successes, which that is 2. Okay, so this, I know the number of trials in advance. Probability of success is given to me. I know that people are independent, and the probability of success doesn't change on each trial. I'm just assuming it's the same. The truth is that there's about a 41% chance that if you're a U.S. household, you have a soccer ball. So the probability on each trial is the same. Okay, so this definitely seems like a binomial experiment setting. Okay, so here's the question. Now we have this formula, probability of K successes is N choose K. This is the binomial probability formula. Okay, and then we had P to the K, and then 1 minus P to the N minus K. And all I'm having to do is answer this question. What is the probability of 2 successes, that 2 households own a soccer ball? And so I go, okay, probability of 2 successes, or the probability that K is 2, like we set up here. Okay, either of those are the same. And then you say equals N choose K. Well, N is 6, choose 2. Probability of success we set up here is 0.41 to the power of the number of successes, which is 2. Okay, and then 1 minus that, which is 0.59, and to the power N minus K. So N is 6 minus K, which is 2, so this gives me 4. All right. And then you just put that in your calculator. You just literally enter 6 choose 2 and that. And if you do all this, you just get 0.31. Okay, 0.31. So, important to recognize, how would I do this besides using the binomial experiment situation? Can't really come up with any other way you would do that. Okay? And then number 5, similar type of question. About 1% of people are allergic to bee stings. Again, this gives me the probability of success. Maybe. Ooh, this is a tricky question. Let's see. Seems like it's 0.01. Alright, what is the probability that exactly 1 person in a class of 25 is not allergic to bee stings? Ooh, 1% of people are allergic to bee stings. Okay, 1 person seems like my K value, my number of successes. Okay, 25 is the whole class. This seems like my number of trials I know in advance. And then also you have to ask yourself, if I know that this is the number of trials, are the trials independent of each other? So if you're allergic to a bee sting, am I allergic to a bee sting? Does your being allergic affect my being allergic? No. Okay. Maybe unless we're related or something like that, but no. So, but now here comes the rub. This says, what is the probability that exactly 1 person in a class of 25 is not allergic to bee stings? Oh, so this probability here is actually the probability of failure in this case, because we're actually asking for the opposite thing. We're asking for what's the chance that 1 person is not allergic. Okay, so this would be the probability of failure actually, which we actually call 1 minus p. So the probability of success, or P in this case, would be 1 minus that, which would be 0.99. If there's a 1% chance that I'm allergic to a bee sting, there's a 99% chance that I'm not allergic to a bee sting. Okay? And so this is your probability of success. This is a tricky question. Okay, you have to read this very carefully. And so now I'm just using the binomial probability formula again. It's the same kind of situation as this, just a little bit more tricky. And so we're asking, what is the probability of that k is 1, or the probability of 1 success. And we can fill in our binomial probability formula. Okay, it's given to us. And so we have 25 choose 1, probability of success to the number of successes, probability of failure to the number of failures. Okay? And if you put that in your calculator, you get something really, really, really tiny. Your calculator probably says something like 2.475. Maybe it says E negative 47 or something like that, which means 2.475 times 10 to the negative 47, which is basically 0. Okay, that's basically 0. It's a very, 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 very small number. All right, there's number 5. All right, number 6. The guayule plant, I don't know how you say that, apologize, which grows in the southwestern United States and in Mexico, is one of several plants that can be used as a source of rubber. In a large group of these plants, the heights of the plants are normally distributed, with a mean of 12 and standard deviation of 2. So this is what we would call x bar, this is what we would call sigma. Okay? Find the probability that the height x of a randomly selected plant, let me erase this out of the way here, the height x of a randomly selected plant is in the given interval. Okay, between two numbers or the given interval. Okay, be sure to draw a picture, include all your calculations and formula used. All right, so I think what they're asking me to do here is this. Okay, here is the distribution, normally distributed. All right, they told me the mean is 12 and one standard deviation is 2. So if I add 2, I'm going to get 14, and then I'm going to get 16, and then I'm going to get 18. Okay, and so on. You can go backwards too. So I get 10, 8, 6. Nice. So that's a quick sketch of normal distribution. The question is, what is the probability that I randomly go here and pick an x, or in this case it would be a plant that is between 7 and 14 inches in height. Okay, and so let me do a different color. So 7 would be right in the middle here, and 14 would be right there. Okay, so since I'm in the middle of a standard deviation like this, I know I can't use the memorized little picture that we had with the 34, 34, all that kind of stuff. You can't really do that, okay, because I'm in the middle of a standard deviation. So what you have to do is say this. The question is, what's the probability that a randomly selected plant represented by x is between 7 inches and 14 inches? Okay, and what we always like to do is standardize these values so that I can use the standard normal distribution. This is a standard procedure in statistics. Haha, zing, standard. Okay, so we do this, standardize, and we say 7 minus the mean over the standard deviation. And then I've turned my x into a z-score, okay, or a standardized score. And then I say 14 minus 12 over that. Now let me remind you where this comes from. Z is x minus x bar over sigma. So for the first one, what I did was, the first x they gave me was 7, so I did 7 minus the mean we were given in the beginning, which is 12, over sigma, which is 2. All right, that's what we're busy doing. And if you standardize, you get this. The probability is negative 2.5. Yeah, that seems right. 1, 2.5. Yeah. and then z is less than or equal to 1 standard deviation. Yep, 1 standard deviation. Okay, and then I just have to find the answer for this. And what you do is plug this in on your calculator. Okay, now I can't show you how to do that right here on my iPad because unfortunately Texas Instruments doesn't release software for an iPad to emulate a calculator. But I'm pretty sure I had a video for this, and I think I'll make another video for this just to show you how to do this again. But in your calculator, you go to, I think what you go to is second, and then vars. Okay, so second vars, and then you go to normal CDF. Okay, normal CDF, remember the C, looks like this, it's number 2. And then it may or may not ask you some things. Okay, if there's a stat wizard that comes up and asks you questions, your lower bound is usually what we enter in this case, the lower bound. So if I'm looking at my picture here, the lower bound is this number and the upper bound is this number. Okay, in this case. So what you would enter for lower bound is negative 2.5, upper bound is 1, and the mean and standard deviation of the standard normal distribution is always 0 and 1. So what you end up entering in your calculator, you don't have to write this on your test, but I'm going to put this down for you. Because some students have older calculators and they don't see the wizard, so you have to enter this. Negative 2.5 is my lower bound, 1 is my upper bound, my mean is 0, my standard deviation is 1. Okay, so let me illustrate for you again how this works. This number corresponds to that number, this number corresponds to that number, this number is x bar, and this number is sigma. Not the ones they gave us, okay, it's not the ones they gave us, it's from the standard normal distribution, because we converted this distribution into the standard normal distribution. In any case, if you do that calculation, what you get is about 0.835. Okay, guys, and we would like you to round to the thousandth normally here. I'm not sure if it's on there. Oh, it says hundredths, but we in AP statistics we usually round our stuff to the thousandth. So I'm rounding to the thousandth. Do what it says on the test. If it says hundredth, you can round to the hundredth. Okay, then you would get 0.84 if you round this up. All right. Okay. Next question. Same scenario. Okay, same scenario. I'm going to draw a much more rapid picture here. Same scenario, but at most 13 inches. So here's the problem. What does at most mean? At most means the biggest I can be is 13. So we said here x bar was 12, and then we said standard deviation is 2, so this is 14. So at most means this. The biggest I can be is 13 or smaller. Okay, that picture is sufficient. That shows me that you know what you're doing. You don't have to go and draw a bunch of, you don't have to draw this whole thing all the time. Okay, and so there's the picture, you did it, and you say, all right, the question is, what's the probability if I go pick a random plant represented by a variable x, that its height is less than or equal to 13? And then we standardize again. What's the probability that z is less than or equal to, and we do 13 minus 12 over 2. That's how you standardize. And you get what's the probability that z is less than or equal to 0.5. Well, that's true. This is 1 standard deviation, so 0.5, that makes sense. Okay. And again, what you would enter in your calculator here, if you don't get the stats wizard, you would enter this. Normal CDF, and in this case, what is the lower bound down there? It's negative infinity, but we usually just enter negative 10,000 because I can't enter negative infinity. Okay, and then the upper bound in this case is 13 for the x, or 0.5 if I standardize, so I'm going to put 0.5. So this number corresponds to that. Oh, let me not close that parenthesis. And then I put mean 0, standard deviation 1. This is the standard normal mean and standard deviation. And if you do the math, you get 0.691. And if you round to the hundredth, that'll be 0.69. Okay. All right. And number 7, very, very similar thing. I think that's number 7 is the last normal probability question. Okay, so number 7 is very, very similar. Question, of course, different numbers, but similar idea. So it says study found that the wing lengths of houseflies are normally distributed with a mean of about 4.6 millimeters and a standard deviation of about 0.4 millimeters. Okay, so 4.6 is my x bar, 0.4 is my sigma. All right. What's the probability that a randomly selected housefly, which we would call x, has wing length of at least 5 millimeters? Okay, so what does at least mean? At least means I can be 5 or I can be greater. So x, well, let me not write x. This means at least 5 means greater or equal to 5. Okay, that's what at least 5 means. So again, draw a picture showing the region of interest. The reason for this is to use so that you show me that you know what you're doing. Okay, that's really it. And I can give you some points for that. So do it. All right, so here we go. We do this, normally distributed, they told us that. And we're looking for at least 5. So 4.6 is x bar. And then one standard deviation away would be 5. Okay, so at least 5, this is what we're asking for. Okay, at least 5. And you see this is very nice. We did one where your randomly selected value is between two numbers, one where it's less than and the other one where it's greater than. Okay, that's pretty standard, so we know you can handle any kind of situation there. So what's the probability that x is greater or equals to 5? The randomly selected housefly has a wing length of at least 5 millimeters. And then I standardize. Okay, so I do 5 minus 4.6, which is the x bar, over 0.4, which is the sigma. Okay, and that's the probability that z is greater or equal to 1. And that's right, 1 standard deviation up, that's right. And you do this again. You would be doing normal CDF, and please, again, you don't have to write this, all right? I'm showing this to those people whose calculators don't have a stats wizard. Normal CDF, and it would be lower bound in this case would be 1, okay? And then going up forever, that's the upper bound, which would be infinity, but we can't write that, so we put 10,000. And then 0 and 1 is my mean and standard deviation for a standard normal. And this gives me the answer of 0.159, and if you round that to the hundredth, it would be 0.16. All right? Okay. All right, number 8. Number 8 says, identify the type of sample described, then tell if the sample is biased, explain your reasoning. Be sure to identify all the reasons for bias, if any. All right. The managers of a movie theater chain want to find the number of movies people in the community usually see in a theater each month. The managers have ticket sellers at each theater survey customers when they purchase the tickets. Okay. What kind of sample is that? Well, it's definitely easy to get to these people because they are at my theater standing at the door. And they want to come in and they have nowhere else to go because they can't. They want to see the movie. So they're convenient for me to reach. They're easy to reach. Okay? So this would be definitely a convenience sample. Alright? That would be the best way to describe this. Not a self-selected sample. Yes, they did choose themselves. But no, they didn't choose themselves to be in the sample because they just went to buy a ticket. I chose them to be in the sample because I went and stood at the door, okay? Or the ticket sellers. So, yeah. All right. So, convenience sample, and we know that, is this sample biased? Yes, this is biased, for sure. Okay, convenience sample is a biased type of sample. Explain your reasoning, and what would happen here? All right. So if I want to know the number of movies people in the community usually see, then I should go to the community. but I'm not going to the community. I'm going to the people already at the movie theater. So I'm missing the population. So you say something like, this is what I wrote on the answer key, people in line to watch a movie are more likely than others to watch movies. Okay, are more likely than general, let's say, community members to watch movies. Okay, so we will overestimate the number of movies community members watch. Right? That's a very, very detailed answer. Okay? What else? I mean, I'm assuming you're going to come up with some other thing like, who's asking the question, how's the question, and all that kind of stuff. This is fine. This is enough. The real problem here with the sampling type is that people are a convenience sample. And that's what leads to the bias, and the bias would be overestimating number of movies people watch. Okay. Number 9. Find the sample size required to achieve a margin of error of 5.9%. For sample size, always round up to the nearest wholest number. Okay, yes. So, that's a little bit of help there. So here's the formula we had. Margin of error equals plus minus 1 over root n. This was the formula we had. Okay? And remember, margin of error expressed as a decimal. So you're not going to put in 5.9. You're going to enter in your formula 0.059. Move the decimal twice. Okay, 0.059. That's the margin of error expressed as a decimal. I want to find sample size. Well, sample size is n in my formula. So I enter the numbers. I mean, you enter the numbers. I wish you could. You just fill in the numbers in the formula, substitute, and you get this. Okay. Remember, margin of error is a plus minus. Is equals to plus minus 1 over root n. And the way I simplify this to get rid of the square root is to square both sides. And if you square both sides, you get this. I'm not going to do anything here because we want to keep this accurate, so I'm going to leave it as that. 0.059 squared equals, and on this side what you get is 1 squared is 1, and in root n squared cancels the square, so I get n. And now what you have to do is do some cross multiplication. Okay, cross multiply here, and this is over 1. You can think about that as being cross multiplication. So I have plus minus 0.059 squared times n equals 1. And then you just divide this out. Okay, and really I shouldn't have to write plus minus all the time, because if I square a plus minus, a plus or a minus, I get a plus. But in any case, I'll keep it like that. So what you get here is plus minus 0.059 squared. So this goes, n is approximately this number, 1 over that. And if you do that calculation, you get 287.27. So you say n must be 288. Okay? We round this up to the nearest whole number. Alright? Okay. Number 10. In a survey of 1,255 people, 39% of them said Lady Gaga should not win any awards until she stops wearing steak on stage. True story. Find the margin of error for the survey. And then it says, so this is one part, find the margin of error for the survey. Okay. and then give an exact interval that's likely to contain the exact percent of people who think Lady Gaga should not win any awards until she stops wearing steak on stage. Alright, give an exact interval. So this is question 2. Margin of error is question 1. And I need the margin of error to do the interval. So again, we go back to our formula. Margin of error is this. Okay. But now, I'm not asked for a sample size. I'm not given a margin of error. I'm asked to find the margin of error. I'm given a sample size. So this is my n. Okay. And this is the middle of my interval. Alright. 39% of people. And I could be wrong in a certain way. And we're figuring out how far off I could be right now. And so margin of error would be plus minus 1 over root, and n is 1255. So you just punch that in your calculator, and you get the margin of error is about plus minus 0.03, or 3%. Okay, so now if I need to come up with a confidence interval, or an interval that's likely to contain the exact percent, it's the 39 plus or minus 3%. So you can do this 2 ways. The textbook likes their percentages here. So I'm taking this 39% of the people who said she should not win any awards, plus minus 3. Okay, and that leads me to a confidence interval is typically written like this. In statistics, 42%, 36% to 42%. If I add 3 and subtract 3, more likely we would actually do decimals in statistics, so you would do 0.36 to 0.42. But since your textbook likes this, either one is fine. Okay? Remember, the margin of error tells me how far over or under am I potentially estimating the truth with my 39%. Right? Okay. Number 11 says, a recent study shows that beta blockers decrease the pulse rate of patients during surgery. The study observed 35 randomly selected patients during surgery who received a beta blocker and 35 randomly selected patients who did not receive a beta blocker. The pulse rate of the patients, okay, so 35 people who received a beta blocker and 35 people who did not receive beta blocker. Okay. Pulse rates of the patients who did receive a beta blocker decreased 76% of the time. Okay. Which group represents the treatment group? So, imposing a treatment means I make someone do something, I give them something. And so in this case, that would be the patients who received the beta blocker. Okay. So, patients who received the beta blocker, and control would be the people who did not receive the beta blocker. So patients who did not receive the beta blocker. Please don't do this. Ditto stuff. I'm doing that because I'm lazy, because we're trying to get through a video quickly. Okay, don't do that. Write full sentences, please. All right. Number 12. Number 12 said, determine whether the following research topic is best investigated through an experiment or an observational study. Explain your reasoning. Okay, you want to know if students who smoke cigarettes earn lower grades than those who do not smoke cigarettes. Best investigated. Experiment, observational. Alright, this definitely observational study. Okay, why? Well, because I can't make you smoke cigarettes and then try to see if that lowers your grades. Making you smoke cigarettes is bad for your health, and lowering your grades is also bad for your health, depending on who your parents are. You know what I'm saying? So, it's unethical. So you say, since it would be unethical to impose the treatment of smoking okay, which is bad for the students' health. And then lowering the grades will also be unethical. If you think something is going to lower their grades, you're also harming them that way. So there's actually two things there. This is enough, but you could say more if you want. You want to study the effect of the use of LED light bulbs has on utility bills. Okay. Well, this no necessarily an ethics, not bad for anybody. I can get volunteers. Hey, who wants to test these new lights? Hey, who wants to just be part of my experiment and maybe not get new lights and see what happens? Okay, fine. So I'm not hurting anybody by not giving them an LED. Everything stays the same. So I think what you can do here is homes. You get people to volunteer their homes. Okay, and the volunteers are homes, and then you randomly assign some of them to get LED lights, and this would be my treatment group, and then some of them to just keep their regular lights or light bulbs, and this would be my control group. And then in the end you can compare utility bills. And remember we said this is called random assignment. Okay? Randomly assign them. So this is definitely an experiment. And the picture is the best way to describe what's going on here. You can write a paragraph if you want, but this is a great little explanation of how you would do the experiment. Alright, number 13. Number 13. About 15% of all Google Pixel smartphones ship with a defective microphone. Okay. Your cell phone contract is due for renewal, and the carrier you use has 9 Pixel phones in stock. Okay. Let X be a random variable that represents the probability of randomly selecting a Google Pixel that has a defective microphone. Okay. Use this information in your calculator to graph the probability distribution for X. What is the shape of the distribution on your calculator? Okay. So this is binomial distribution. Seems like it. Okay. We have the probability of success here. Excuse me. Which is 15% is 0.15. And we have our number of trials is 9 Pixel phones. Alright, now the problem here is they're not asking for a probability of a specific success. They're asking for the whole probability distribution, all of the options. Okay, so think about this. If I go to buy a smartphone, alright, and there's 9 in stock, what is the chance that I pick one that's defective? Okay, it's 15% is what we're told. But now you have to think about all the options. I can pick one that's defective. I can pick none of them that's defective. I can pick 2 that's defective, because we want the probability distribution for all the options. Even though I'm only buying one myself, maybe you're like 2 phones, but so we have to think about all the options. So all the options is what we usually put in list 1 on our calculator. So you would enter something like stat, and then edit, and then under list 1 you would enter all the trials, all the options for successes. Well, there's 0 successes. I don't pick a phone that's defective, or 1 phone with a defective microphone, or 2, all the way up to 9. Okay, enter that in your calculator, and then when you go to list 2, in list 2 you want to go up to list 2 and say equals, and then you're going to enter this information in binomial. Oh, let me write that properly. binomial PDF, and you're going to put in 9 trials and probability of success 0.15. Okay, and hit enter, and everything will get magically populated. And then step number 3 was to adjust your Windows settings, which if you did that, you'll see that your biggest probability that came out of here was like 0.036 or something. So I would say that your Y max should be like 0.4. Your Y min can be like negative 0.1, something tiny. And then your X min could be -1, and your X max, remember X is the number of trials, should be 10. Then you're one bigger than this. Okay. If you do that, you get a. Now I'm going to do this very roughly. Okay. You're going to get a graph that looks something like this. A rough little sketch here. Something like this. And then there are bars here, but they're really tiny. You can't really see them on your calculator. Okay. And this would be 0 and 1 and 2 and 3 and so on. So this distribution is very heavily right skewed. Okay, right skewed. That's what you would put. There is a tutorial of how to do this on your calculator on Schoology. I'll let you go look at that. Okay, I'm pretty sure. If there isn't, I'll make one, but I'm pretty sure there's one. All right. Number 14. Let y be a random variable that represents the number on the face of a 6-sided die when you roll it. Okay, we did this example together in class, except we didn't make the distribution for it. So the possible values of y are 1, 2, 3, 4, 5, 6. Use this information to graph a histogram of the probability distribution of y by hand. Label each axis and so on and so forth. Okay, make sure you label everything. All right, so we did this. X, what did we say, y? I think we said y because we used x earlier. Yeah, we used x here, so we're trying not to confuse you, so we're using y. Okay, y is my random variable that is the number on the face of a 6-sided die when you roll it. So it's a random process. So the options for y are 1 and 2 and 3 and 4 and 5 and 6. Okay, and the probability distribution is the values of the random variable, which we just did, and then the probability of each outcome. Now, the question here that's different from other ones, this makes this easier, is how many ways when I roll one die can I get a 1? Well, that's only one way a 1 comes up, okay? And how many total options are there? So this is a classic definition of probability. Probability of any event is the number of outcomes in the event over the total number of outcomes. So when I roll a die, how many options are there for getting a number on the face? Well, 6 options. I can get 1 or 2 or 3 or 4. Okay, so this is 1 out of 6. But the chance of getting a 2 is also 1 out of 6. And the chance of getting a 3 is also 1 out of 6. They're all the same. We did this together. Okay? Because there's only one way of each of those things happening. And so all you're doing here is you're putting down the values of y, all right? And what you have to do is do something like, this is 1, this is 2, this is 3, 4, 5, and 6. Those are the only options. Remember, when we're talking about binomial, we're saying number of successes. The smallest number of successes I can have is 0. I can have no successes. But this is not what this is. This is saying the number showing on the die after I roll it. So the smallest number it can show is 1, the biggest is 6. And then the probability of that outcome y, all of them are 1/6. So if I put 1/6 here, and then I can just make my bars. Now, this is interesting. They're all the same. So let me do it in a different color. Here is the height of the first bar, but they're all the same. This is called a uniform distribution. Okay, they're all the same. All the bars are the same height, same chance. And that's it. That's your distribution, probability distribution, histogram graphed by hand. Okay, histogram. This is the histogram. This is the table of the probability distribution. All right, guys. I hope that helps you. Yeah. Any case, have a nice day.